Hi, Assalamualaikum. Welcome back to Miss Reni's class. Today, let's learn about the effect of temperatures on the rate constant. But before we start, let's say Basmalah together. Bismillahirrahmanirrahim. Okay, the effect of temperatures on the rate constant. Yeah, so here it says that at higher temperatures, a greater proportion of molecules have energy greater than the activation energy. So it will become this formula. We call it as the Arrhenius formula. ln K equals to ln A minus EA per RT. So I need your good mathematics skills here. Be careful on using this formula and also on insert this formula on your calculator because we use ln or natural log. And then here R is the gas constant that is 8.31 joule Kelvin minus 1 and mole minus 1. Okay, so this formula can be used if we know all of the information here. For example, K as a rate constant, A is a constant related to the collision frequency, EA is the activation energy. But if we don't know more than uh, one information there, it can be hard for us. But actually, we still can use this formula by as a help of using another formula that is coming from a line equation. So, yes, do you still remember what is line equation? Yes, y equals to mx plus c. And then if we relate with the Arrhenius equation, it becomes like this. So y will be the same with ln k. M equals to 1 per t. And then, x equals to 1 per t. And then m equals to minus EA per r. And then c equals to ln A or y-intercept. And then I can plot it into a graph. And then this is a graph. So ln k will become y, and then 1 per t here in our x line. And then it shows you the straight line. Okay, it's a time to practice. This is a question. A particular reaction has a rate constant of K equals to 2.3 times 10 to the power of minus 3 at 20 degrees Celsius and 4.3 times 10 to the power of minus 2 at 90 degrees Celsius. And then the question is, what is the activation energy of the reaction? How to solve this question, everyone? Do you know? So actually, yes, we relate with the line equation because we don't know A there. The question didn't provide A on the question. So that, yes, we use the line equation and then we go to. So we have this formula and then just substitute into this formula. So the high temperatures become the T2. Don't forget, we have to convert into Kelvin because it's still in degrees Celsius. And then the rate constant on that temperatures become K2. And then the lowest temperatures become T1. And then the rate constant on that temperatures become K1. And then substitution. And then after that, we will got EA. So substitute. And then don't forget here we have natural log. Be careful when you use your calculator. And then at the end, we will have this as the EA number. We can convert into kilojoule because the number is bigger. So divided with 1000. That's it. Actually, it's simple. I just need you to be careful on insert the data and on using the calculator so you will not get missed on the final result or the final number. How is it, guys? Do you understand? All right, so it's your time to practice now. I have another question. Here you are. So let's find the activation energy. write your own answer in your own workbook and then please show it to me on our next meeting. Okay, everyone. I hope that's all for today's lesson. I hope you understand. And if you still have a question, do not hesitate to ask me. So, yes, that's it for today's everyone. Let's close with saying Hamdallah together. Alhamdulillahi Rabbil Alamin. See you in our next meeting and Assalamualaikum warahmatullahi wabarakatuh.